Today's lecture is on metamorphic rocks. We have already done igneous, sedimentary, and now we're going to do metamorphic rocks. Let's take a quick review. Remember, igneous rocks were those rocks that are formed from melted rock material. These are magma or lava, depending upon where it cools. And we also know that igneous rocks can be classified according to their composition and their texture. Typical example, if it has an abundance of feldspar and quartz, we call it felsic igneous rocks. Granite is an example, and so is rhyolite. And if we have some that are mafic, these are the ones that have an abundance of minerals that are higher in iron and magnesium, and therefore they're dark in color. And so we say that these are basaltic. And examples would be basalt and gabbro. Then we also talked about the texture of the rocks, and the texture has to do with the cooling rate. And so if the melted rock material cools extremely fast, there are no crystals, so the texture would be glassy. If it has a mixed cooling rate, whereas the magma is cooling very slowly far below the surface of the earth, it gets large crystals, but on its process of moving toward the surface of the earth, and sometimes it does, and they even come out of volcanoes, then that particular rock would have mixed crystal size, and we say that it would have a porphyritic texture. Sedimentary rocks, on the other hand, we normally think of those as rocks that are made from bits of sediments that are cemented together, and we call the process of sedimentary rock formation lithification, and it requires two things. The sediments have to be compacted and they have to be cemented together. So we say that those two terms are compaction and cementation. The sediments are classified according to their size. Extremely large ones, we say that that would be gravel and sand, we have silt, and then we have clay. And the rocks that are formed from them are certainly different. Those rocks that have large, rounded gravel in them that have been cemented together, we say that this is a conglomerate. Sandstone is made from bits of sand that have been cemented together. And we talked about three different types of cementing agents: calcite, silica, and iron oxide. Well, today we're going to talk about metamorphic rocks. If we talk about metamorphosis, it means that whatever it is, it's going to change in form. So a metamorphic rock was at one time another kind of rock, but it was exposed to extreme heat, pressure, and chemicals, and then we got another type of rock from it. Remember now, when we say that it is exposed to heat, it's not enough heat so that it melts, because if it melted, we wouldn't be calling it a metamorphic rock, we would be calling it an igneous rock. All right, now metamorphic rocks are changed from, that means that these rocks are changed from one type of rock to another. And so we call the original rock that has been exposed to any of those agents of metamorphism, like heat, pressure, and chemical, we call that the parent rock. For example, when limestone is exposed to extreme heat and pressure, it becomes marble. So the limestone is the parent rock. All right, then there are changes that result in rocks due to metamorphism. Rocks that are exposed to these agents, they have an increase in density. They grow larger crystals, and you will see this as an example when I show you sandstone, and then you compare it to quartzite, the metamorphic rock that it becomes. And we can also get a type of texture that's referred to as foliation, because we get the reorientation of minerals into layers or banded appearance. And I will show you an example of a metamorphic rock, gneiss, Gneiss, that has that foliated or banded appearance. And then other things that can happen is that rocks can have a transformation of low temperature minerals into high temperature minerals. All right, the types of metamorphism include regional and contact metamorphism. Regional metamorphism is widespread and it's usually caused by pressure, mainly by pressure, and it's found in mountainous areas. And I'm sure you've gone to the mountains and you've seen examples of rocks that look like the layers at one time could have been flat, but look like somebody has kind of folded them up. And that's an example of what we're talking about, regional metamorphism. Contact metamorphism is formed by intense heat as well as pressure. And so the magma, when it comes in contact with the rocks that it actually touches, they are metamorphosed, and we call that type of metamorphism contact metamorphism. And here's an example. When you look at this, you can see, for an example, here's a magma, and then you see that it's making its way up to the surface of the earth, and wherever that hot magma touches those rocks, that's where contact metamorphism occurs. And this one, of course, is showing what happens when we have regional metamorphism. And you can see most of this is pressure. Because look, the rock layers right here are basically horizontal layers. But look, because of the pressure on both sides, you see how it's like they're folded? So that's regional metamorphism, and you can see evidence of that in mountainous areas. Okay, the texture of metamorphic rocks. Now, we've learned textures quite a bit when we were on igneous rocks, but for metamorphic rocks, we're going to only learn two textures. One is foliated texture, and the other one is going to be non-foliated. All right, that one is foliated. This has a banded appearance. Look at this one. That's nice. See, lighter color minerals, and then the dark color minerals, lighter color minerals, dark color minerals, and it's talking about a banded appearance. And so when you see rocks that have this, it is referred to as foliated texture. And this is one that's non-foliated. You just see large interlocking crystals, no bands. And this is non-foliated texture. And here's an example of another one, non-foliated texture. Now remember I told you that metamorphic rocks, there are two different textures, and metamorphic rocks at one time used to be another type rock. So on the left of the screen, when you see these pictures, and here I go again, those are the rocks that will have foliated texture or the banded appearance. The ones on the right will be the ones that are non-foliated. When I talk about the name of the rock, I will also tell you what its parent rock is. All right, gneiss, for an example, is the metamorphic rock, and you will see sometimes as you look that it could have started off being shale, which is an example of a sedimentary rock, or it kind of looks like it could have been granite. So any of those would be an example of what the parent rock could be like. In your book, within chapter 3, is a table that has metamorphic rocks, and it also has the parent rock. All right, marble on the other side is non-foliated. Marble used to be limestone, but it has been exposed to heat and pressure. So we have marble, which is non-foliated, that used to be limestone. Gneiss, which is foliated. All right, slate kind of reminds you of a sedimentary rock that you saw on the sedimentary rock layer, which was shale, which is made up of those tiny particles of mud or clay particles cemented together. And when shale, the sedimentary rock, is exposed to heat and pressure and becomes the metamorphic rock, slate. So slate's parent rock is shale. Quartzite, if you look at the name of this, quartzite kind of reminds you of the mineral quartz. So quartzite, we normally think of quartzite as being the non-foliated metamorphic rock that was at one time sandstone. And then here's schist, and schist, foliated texture, and it could have been slate, which was a metamorphic rock that was formed when shale, the sedimentary rock, had metamorphosis. And then anthracite, which is hard coal. And anthracite, before it became hard coal, was bituminous, a soft coal, which is an example of a sedimentary rock. Now this table shows rock names, textures, grain size, comments about them, and what the parent rock could have been. For example, excuse me, quartzite is a metamorphic rock. Its texture is non-foliated, all right? And quartzite could have been quartz sandstone. That's the parent rock, okay? And then we have another one, anthracite, which is the hard coal. And so then its parent rock, we know, was bituminous coal. And we move up here, we go foliated, a banded texture. And look at the examples. All right, you know, this one is nice. And it could have been schist or granite or another volcanic rock. And then if we skip up to the one at the very top, we get shale, which was the parent rock. And so that means that this is now slate, okay? So remember, rock names, the textures, two textures only in metamorphic rocks, foliated and non-foliated. And then we know what the parent rock, that is the rock that it used to be before it was exposed to heat and pressure. Now, since we have 3 different types of rocks, and based on listening to the lectures, you see that the rocks are not formed the same way. So rocks can undergo changes, and we're going to see this. Now look at this diagram. And please don't think that because there's a diagram either in your textbook or if I put one as a part of a PowerPoint that it's just there to take up space. The diagrams, actually, you could learn a whole lot from them. Follow along, please, as I go over this with you. Remember, igneous rocks can be intrusive, formed below the surface of the earth, or they can be extrusive igneous rocks. Now let's take an intrusive igneous rock, and we're going to cause uplift to occur. It's going to be on the surface, and if it's on the surface, it's going to be exposed to weathering, like wind and rain, all of that kind of stuff that's going to break it up, and that's weathering. All right, if you break up the sediments into smaller particles, I'm sure you travel through the mountains and you've seen signs that say, watch for falling rocks. Well, what happens is that when the weathering occurs, and we get these small sediments, gravity is going to cause them to fall. And so weathering breaks the sediments up, and we have transportation. That means erosion moves them from up here so that they end up down here. Okay, so we have these sediments that have been formed because the intrusive igneous rock is broken up. They have been transported or erosion has taken place. those sediments have been buried. And when it says sedimentation, that's the big word we learned, lithification, or those sediments have to be compacted and cemented together. And when that occurs, we get a sedimentary rock. So we started off with an intrusive igneous rock, cause uplift to take place. Then, and here I go, this computer is so sensitive. And then we have erosion, or this says transportation, and then lithification here, and we get the sedimentary rock. Now, if we follow this diagram, we're going to see that there are changes that can take place with the sedimentary rock. If that sedimentary rock is buried, and there's a whole lot of heat and pressure, it can become a metamorphic rock. But if there is a whole lot of heat that occurs, look what could happen to that metamorphic rock. It could melt. If it melts, we're going to get some magma from it. And if we get that magma, we can get an igneous rock. Some magma may find itself on the surface of the earth and become an extrusive igneous rock, or it might cool and crystallize below the surface of the earth, and we get an intrusive igneous rock. So look, sedimentary rock can be buried deeply, exposed to heat and pressure, and become a metamorphic rock. That metamorphic rock that it becomes could be uplifted on the surface of the earth. And if it does, it will be exposed to weathering, erosion, and we can get a sedimentary rock out of it. So what I've gone through with you, but looking at this diagram, is to explain to you the changes that can take place in rocks depending upon the environment that they're in. And that, I was leading you into what we normally refer to as the rock cycle. And let's look at it simple. See this little diagram right here? And it's color-coded to kind of help you to figure out this. Igneous rock. And here we have this. If we're going to have sediments out of the igneous rock, we got to have some weathering to take place. It has to be broken up. See, big rock, little pieces. All right, and then that sedimentary rock, we have to have lithification, or we could say compaction and cementation. Here we are with our sedimentary rock. All right, and this shows that if we're going to get a metamorphic rock out of it, it says metamorphose in here. That means that we have to expose it to heat, pressure, chemicals to get the metamorphic rock. If that metamorphic rock is exposed to a whole lot of heat so that we get melting to occur, we get magma. That's liquid rock material. All right, and that magma, in order to become the rock, has to cool. And so we refer to the process of igneous rock formation as crystallization. Okay, but look at what could happen to this igneous rock. Here we go. This igneous rock could become magma again. Heat it up so much that it melted, and we could get an igneous rock when it cools. Or that igneous rock could be exposed to heat and pressure, but don't melt, and we can get a metamorphic rock out of it. All of these are showing possible changes that could take place in a rock depending upon the environment it's in. Metamorphic rock, broken up into sediments, little pieces, and those sediments can become sedimentary rocks. Okay, so now we have reviewed quickly the three types of rocks: igneous, sedimentary, metamorphic. And then we talked about metamorphic rocks in detail. And then that led us to the rock cycle. Have a good day.